Alright guys, now that you've done a couple examples on your own, I want to talk you through them just to make sure we're good. The first example says we're going to find the measure of arc DC. So let's make sure we're finding this measure of arc DC. Notice what they give us. They give us two congruent chords. And in the same circle, when I have two chords that are congruent, that means that their arcs are also going to be congruent. So we know that if they're congruent, that means they have equal measure. Let's write our equation. We can say that 3x plus 11 is equal to 2x plus 48. Okay, now if we go ahead and solve this equation, we could go ahead and subtract our 2x from both sides. So x, and if I subtract my 11, would equal a 37. And if I substituted in, it shouldn't matter which one I substituted in because these two should be equal. 3 times 37 plus 11 is going to give us 122. And if you check it over here, 2 times 37 plus 48 would also equal 122. Now, we're supposed to find the measure of arc DC though. But we know that all together they make a whole circle, so to get just DC, if I took my 360 degrees and I took away the 122 and the other 122, you should be left with 116 degrees. So the measure of arc DC is equal to 116. All right. The other example that you had, it said we were supposed to find CG. So we're supposed to find this measure right here. Now, I'm going to go ahead and label the picture. We know that AB was 12. That's this whole measure. And we know that DE was also 12. Now, take a look. We have two congruent chords. And we've learned several things about congruent chords, one of them being that if we have two congruent chords, then that means that they're the same distance, they're equidistant to the center. So this measure x is also going to be this measure x. That's a measure that I'm looking for. Now, we also know that CE is 7, so a radius here is 7. Now, I can't really do much with just knowing this measure x up here and knowing that this is 12, but if you take a look, we have a right triangle, and I'm going to go ahead and just draw that right triangle that we have. All right. Now, in this right triangle, we have x and we have the radius was 7. We know that if this whole segment DE was 12, well, this radius that I have, or sorry, this segment I have here, if it's perpendicular, it would have to be part of the diameter because it's perpendicular to a chord. It would also be bisecting the chord. So this should be our 6. Well, now we've got a right triangle. We could go ahead and use the idea of Pythagorean theorem to help us to solve to find a missing part. So we could say x squared plus 6 squared is equal to our 7 squared. So x squared plus 36 is equal to our 49. So x squared would then equal our 13. Not very pretty. X would end up equaling, we could say plus or minus, radical 13. Now we know that we're not going to ever have a negative segment length, so we can kind of ignore that negative. It's an extraneous solution. So we could just say that x is radical 13 units long. Now x was referring to CG. That's what I'd marked up here with CG. Since they ask us to find CG, we wouldn't want to leave it just as x equals. We would want to say CG is equal to radical 13.